Hello, this is a video on Jane, on our computer technology and the changes that I want to see. This one is on the cell, or a value that we want to manage. This is what computers do. We take information and we perform logic on them. So the cell is a container for a value and for all necessary and related information. So necessary by default, software in our current software development technology, we basically go to a name and a value. And then the value has information about what data type it is, if it's an integer or number of bit, the length of it, and that's about it. We don't really have very much information right now. We hard code all that information in the source code, and we hardly ever give that out. For us, we're talking about shareable information, so we want all the information that we know. And one of a big one, which is units, which is be nice to know, age is 12. 12 what? 12 weeks, 12 months, 12, and all of that's hard-coded in our applications right now. I want to move all this information out into our cell value, our container, and then we can move that around instead of hard-coding it, because it really makes no difference to the logic. Whether I get the length from the cell itself or from being hard-coded. So on a cell is both singular and plural. So if there's one, it's singular. If it's more than one, it's plural. And it's in memory, or it's attached to a stored cell, so we can edit it. We'll bring it into memory, edit it, and store it back. Or it can be a copy of it, or portions of it. And cells are dynamic, created at runtime, or it's static at compile time. And values in the cell are either temporary or permanent, and it's partitioned. In our current technology, we don't have any partitions that are not hard-coded in our applications. Here, we want to be able to physically separate our cell, because most information is, we generally partition things simply from size, okay? If we don't need to pull in the whole thing, we'll partition it into records, or blocks of records, or by date, or by month, or by department, or by company, or country, or a billion other physical partitions that we only want to really load in what we actually need for a particular purpose. And being physical doesn't necessarily mean that we can't edit all the partitions at one time. And so there are no versions of a cell. Basically, it's not shareable if it's versioned. So I have an application, I create a data structure, let's say an employee record, and I want to add a new field, we just add it. The application does not assume anything. And so all the information in the cell, if it comes up and they put in, whether he has a commercial license or not, we've never done that before, but we hired a couple truck drivers, we just add it. We don't have to change. So last year we didn't have that information, so all those records don't have it. The new records do. If we don't have it, we don't have it. That's as simple as that. We don't need to be trying to share and convert old records into new formats, so nothing is ever converted. And each cell has a unique identifier. And we have cells per all of our hardware devices. So basically any information that we need to know, or the application needs to know about a device, how to read it, what our CPU instruction set is. Our CPU instructions should come from the CPU itself. Say, CPU, what are your instructions and what is the format? And then we load that in, and then we can build compilers that are built for that particular machine. So instead of being hardware dependent on all of our applications, we could actually build them dynamically when, here's my application, go ahead and build it on that machine, and we can do this. Cells can contain other cells. So it's a folder, if you wish. So it's both a container and a directory. So we have a computer, and what we'll do is we will attach a cell to it and give us all the information that we want to know. Some of the information be, what is this? Is this cell relating to a computer or to a mouse or whatever, or an application? So we associate, by default, hardware device to a information packet. And we can put the name in there and maybe the cost and where we bought it, or some of this information can be like the IP and the IP4 and IP6 and all the other all the other information that the operating system has and all that. So we can do that. So, and then we can associate all the devices that this computer has. So that could be another cell that has all the devices, or the CPU, which is another cell. So we're pointing to other physical device blocks that we can load when we need that information. We can have multiple operating systems, and then with COS is the current operating system, or whatever structure we want to build. And this is up to the user. The system will build some of this for us, but we can always add. The cell is designed to be shareable. That's our current computer technology. Nothing is shareable. Absolutely nothing. It's documentation. You go out there, what format is the number in? You got to go look at documentation. The system will not tell you. It's hard-coded into a single application. So we write single applications. We hard-code in all this information. And then the application says, I know that information. Instead of going and having the information itself tell you what that is. Same way with the hardware. So we should be hardware independent and application independent, but we're not. And so most of the information in our current applications are only known by the programmer. We have no units. So what units is it? Well, I hope somebody knows. So basically we're in our current technology, sharing is done through calling functions. So functions is a client-server technology, which says this function calls that function, this client calls that server and says, here, perform an action. But it's all manual. Means that the programmer has to, what are the names, has to go to documentation to do this. We can get rid of this by going to a cell structure. So the cell is designed to be shared. It's designed to be shared by the application itself. So if I have multiple processes, I can just send it the information that applies to that particular logic. If it has graphics, I want to draw it, I just say draw graphics. And that system is dynamically loaded, but we won't get into the application. This is just the content of the cell and the purpose that we want to perform. And so if we can share with our own application, then we can share with any other app. And we have better flow control does a lot of this. In our current technology, this really doesn't work. We have to get better flow control, and then this really works far, far superior. Because we're stuck in this client-server mentality, which doesn't work. This function does not know what that function. A lot of this we don't even know. We make assumptions on everything. We want to get where there are no assumptions. And so a cell may require logic, so we can attach logic to it. Look up tables and formulas and whatever else we need for that particular cell that's unique to me. And I say, look, I'll share that. So when you load it, you have those lookup tables and those formulas. And a lookup table says it can only be red, white, and blue. That's what I need to know. And that's my logic. But you can go in and do whatever you want to with it. But most likely you want to know, okay, here's the lookup table. 512 means x86 CPU. We have so much of this enumerated logic that we spend all our time looking these things up. So I'll look at an application cell example. So here I have an application. I'll just call it app. And generally we attach a cell that puts in the name and the purpose and maybe the programmers and some various details about it. But then we also have all the programming scripts, the source code and the text files and whatever else the source code needs. So we can separate that into a separate cell but attach it as a child. And we have install scripts. So this is one application we associate and actually stick physically in that cell or references to it, either physically or partitioned, those scripts that install it, and whatever it takes. And then we can even store the executable that this application, so we can have the cell, which is the application, which has all the source code and the scripts and even the executable. So when you say run this app, it just pulls that. Since it's partitioned, it's exactly what we have today. No difference, it just looks different. And then we can attach documentation if we need, and we can even attach where this cell association is. This is a big thing. We need to know context and everything so that we know this app is in the projects of applications and it's whatever. So the end user, designs and builds this structure. It will be designed for you in most cases, but a lot of times you want to override that and say, look, I want multiple project types. We want to get out of our database mentality. We have a cell and we want to cast it. Okay, what am I talking about? Casting. So we take a specific data structure's technology. So we have a data structure. Let's say it's an employee record. We can cast it as an employee. Place it by term. So is this a person, place, or thing? So we say an employee is a person. So we need to make sure that this is what we're talking about. It's not a place. He's in Houston, that's a place. So we have to make sure that we associate these terms properly, so that when we do share them, everybody else knows what we're talking about. All of our logic is load on demand. Our values are load on demand. We want to get to one computer language in managing our system, period. We don't want thousands of scripting languages and thousands of computer language, so on and so on. We want one so that we're not jumping around from application. We're not having to write in 4 or 5 different programming languages and 10 different scripts, and we want to get to variable and fixed length numbers so that we're not limitation by 64-bit. We can go to variable. We can do both. We can do all of this. It's just software. And we want access to all the devices that we have, the mouse, the screen, and so on. So we want to go to there. And we can have custom parsing. So we can say, hey, the street address and anything in parentheses is parsed by the street address logic. In the same way, we can do name equals value parsing, which is common. And so we could use braces or some other syntax to say, compiler, go ahead and parse these out for me. It's the same structure. So when I say cast, means that yes, we have a data structure, but we can apply different logic. This is a little bit different than our current, where we build a class or functions that apply to a particular data structure. Here we're going the other way. We have logic that can be applied to any data structure. So we can cast it as an employee. So all the logic that we want to deal with employee, what's his job title, how much is he paid, all this other information. So that's the type of information we want. But we could also cast it as a record. Okay, what values do we have in there? And then search those, and what data types, and then what units, and all the other information about the internal structures of this, so that we can validate and make sure that somebody hadn't slipped something in or whatever. Or we could cast it as a person. The person has a height and so on. The employee, we're not worried about. It's our intent on what the purpose is. That's why we're going to sharing, so that we can share this with all the different logic that can be applied. So if I'm worried about, his age and things like that, then I would probably want to associate it to the person, not as an employee. Or we could say it's human. Humans have height and weight, have heart trouble, whatever we want to associate as being a human. It's the same information, but we can cast it, apply different logic to it based upon each user's exact purpose. Or we could cast it as a manager of operations, or we could cast it as hexadecimal. Let me see, this whole thing is in a hex dump or whatever, and 1,000 other types. And so we have cast logic and value access, which is our verbs, which is, cast logic is loaded on demand. So when you say employee and you now want his name, then the logic is only loaded when we actually perform that statement, not make an assumption that we need it at any time. And so a cast is a logic module, and it resolves its own name references. It might be on a different machine, And so that A.X, X, A is on a different machine. We don't know what the structure is, so we have to ask that other machine. And so that's why each cast must resolve its own name reference. And a lot of it can be derived or just looked up, does that file exist, and load that. And values are loaded when used. So machine to machine, if I say employee Cliff, it's not loaded when I reference that. There's no reason to load it because I don't know what I'm going to do with it. I may just want to know if it exists or something like that. Values in a cell are temporary and or permanent. Partitions can be accessed separately or as a unit. This is things we want to be able to do. Look, we have our source code and it's broken up into functions. We could separate that into permanent partitions, access them and edit them individually, or edit them together and let the system, our editor, manage the partitions and store them back where they need to go and so on. And so we want to eliminate client-server technology. So basically, client-server doesn't work. When you have two people trying to communicate, the client says, get a loaf of bread, and the server says, I don't know what that means. The server is doing what it wants to do and has no idea what the client wants to do. We've got to eliminate that and go to shared execution of logic, not pre-canned logic by somebody who has no idea what the client is doing. This doesn't work. And we got to get to hardware security. So my conclusion is we want direct storage access. So this is done for us. We want readable source code. Right now, the only way we know if an application runs is to run it. We need to be able to read the source code and determine exactly what's going to be done and trust that. We don't have that. I've never seen it. So we're going to have a cell explorer, browser, editor, and database. So basically that's what it is. And it opens up and it tells us what's there and we can edit it and different views. And so if we get into an executable, it has every bit and byte will be accessible through the browser or through the explorer or the editor, or treat it as a database so we can apply SQL statements and whatever else we want to apply to our database. Trigger. We want cell locking, so we have shared access of all of our information from any machine for any purpose. And we want user-specified security, so that we're not relying on some generalized security. We want to be able to lock it down to our security for our company. That's what we need to get to. I don't trust anybody. I don't trust that the government wants to listen to our phone calls. We could secure our phone calls. We could secure our emails and so on as an individual. And so it's not a general type of security where somebody's got the key. Who knows? We have no size limitations. We have one cell, the universe, to start from. So this is everything we know about all the machines that we're familiar with, and all the information about each of those machines and cells, and so everything is organized for it. This is organized before we get one bit of information, and everything's in context. So when I say Fluffy, he's my cat, and I know everything there is to know about that. And we have dynamic name resolution, means that it's no longer, our current technology is we stick things in global or we stick them in local, and that's pretty much our whole technology. Here we don't do that. We tie it to the data structure itself. So this data structure is being used for this purpose, let's say graphics. Then the name resolution for graphics, if that's our context, is then determined from the information itself and from the logic module, not from, we'll make the programmer store it in and hopefully organize that. There is no organization there. We want everything organized. And we want context of the cell. We want the visualization of the context to be built into the compiler, so we're not doing this work. We want the digital representation and the text representation. So if it's math, we want to see math shown as we would write on paper. That work should be done for it, and not make every programmer come up with his own way to do these three pieces of logic. All right, that's it for this time. I know this is very raw and rough, basically because there's a lot more to it than this. I've tried to just cover the basics, not get into details how all this is going to actually perform. We'll get Jane out, and this will all be built in for us so we can actually see it. There is no programming involved here. This is all access to information and apply logic to it. And then the logic modules are actually cells so that they have their own content. Well, thank you. Have a great one. Bye now.